Okie dokie. It has been a long time since I've streamed, so sorry about the silence there. What we're going to have a look at today is go through the process of how to unbrick a MEGA65 when it's got into a particularly tricky state, which is when the main FPGA, the one that you normally think about with the MEGA65, is programmed. And the second FPGA that most people will never interact with or aren't aware that they are is the MAX10 FPGA that does a few important things. So if I lift the lid on this MEGA65 here and try to move that cable out of the way a little bit, this job here is the main FPGA that we're all familiar with. That's the Xilinx R3A 8200T FPGA that actually runs the MEGA65 core. But there's another FPGA, and you can't see it in this picture yet because it's hiding under here. This one here is the MAX10 FPGA, and that was added to the MEGA65 board design so that there was a way to unbrick the MEGA65 if the main FPGA ever got itself completely botched up, like if the flash rather was completely screwed up. And the idea was that you would be able to, from the external micro SD slot, you put a card in from the outside and be able to either have a funky cable. I can't remember, to be honest. I think we were thinking about having a JTAG cable you could put in from the outside so you'd never have to open the box. And then be able to load a bit stream in that way. And the idea was also that actually the MAX10 would be able to talk to the SD card controller, and it would be able to load bit streams directly from the SD card into the main FPGA so that you wouldn't be limited by the slot number that fits in Flash. We never kind of got around to implementing that because it's going to be quite fiddly to do. And yeah, so it's there. And there's this unfortunate interaction where if that FPGA is not programmed, then there are some interesting things that won't work, because the keyboard goes through it so that you can, you could use the keyboard with that funky mode that we're planning, and the JTAG for the main FPGA goes through it so that it would be able to do the JTAG control of the main FPGA, and that's okay. That kind of makes sense because you just go, well, that's all right. You just need to program the MAX10 to be able to access the JTAG the way that we normally do through the regular JTAG port on the MEGA65. But there's a little trick in there, which is that the MAX10 is set up so that it only has its JTAG enabled when the main FPGA isn't programmed. So if neither of them are programmed, like at the factory to begin with, then that's fine. You program up the MAX10 and then and write to its flash, and then you do the same with the main FPGA. Hey, Andy Magic Knight, just having a look at the chats there. Thanks for tuning in. Hopefully it's of interest. Chuck questions in as you go along. So anyway, so the problem can come about if the main FPGA has a valid flash slot, but the MAX10 for some reason doesn't. And we first encountered this a year or so ago, I reckon, where someone had tried to upgrade the MAX10 FPGA because it also has access to the HDMI power and a couple of other things, and it was getting itself confused with the reset switch and causing some flickering HDMI for some folks. So a few folks have updated it. We discovered in the process that because its JTAG lines are connected to that micro SD slot as well, if you have a micro SD card plugged in and you try and flash the MAX10, it fails. And so we ended up in this state where the MAX10 wasn't programmed and the main FPGA was, and had to come up with a solution. So we did at the time. It was a little bit kind of, convoluted, rub your tummy and pat your head kind of thing. And now someone else has got the same problem. I'm not sure whether it's the same root cause or whether it's a different root cause. But we just need to, to reactivate that memory of how we did that, and in the process of simplified it considerably. And so we'll go through that process today. London was asking, yes, is this for dev so we can unbrick the board? Yes, it is. Yeah, and so London's also saying this is why he never uses the micro SD slot. So actually the micro SD slot is totally safe to use, just don't try and flash your MAX10 FPGA while you've got it plugged in. This is not something you can do by accident. You have to plug in the JTAG adapter onto the port for the MAX10 and be doing things. So it's all fine. That said, I actually never plug anything into the micro SD slot, because for me, I just keep my MEGA65 unscrewed. If I want to pull the SD card out, I just lift the keyboard off and do it that way. But to each, to their own. So, yeah. So anyway, let's have a look at, so this is my development MEGA65 R3A machine. So this is the same as the retail ones, which has the 8-slot flash. And I've pre-prepared this to be in this brick state. So if I turn the machine on, what we should see is the ambulance lights. And if I split the screen across like that, you can see that the cursor is blinking really fast because it's getting weird things from the keyboard, it thinks, because remember the keyboard goes through the MAX10 FPGA, which is currently off to the side drooling, and so if I type on the keyboard, absolutely nothing happens. So this is what the symptom of the problem tends to look like. And howdy to the other folks who have lurked on. Good to have you along. So let's go through how we will fix this problem. So the first thing we need to do, we need to be able to flash the MAX10. Remember what we said? The main FPGA needs to have its, it needs to not be programmed, so it needs to be not running a MEGA65 core at the time. Now, without the keyboard, this is tricky to arrange, right? So what we do, I've made a special version of the Hippo hypervisor file that we can put on the SD card, because fortunately the internal SD card isn't going through the MAX10. So just put this other stuff out the way off my desk. Okay, so what we can do, again, we'll lift the lid, pull the SD card out because we can't run MEGA65 FTP. I will plug this into my Linux machine, and I can from there bin. We can copy this brickup.m65 file. So this is this special one that's designed to actually stop the MAX10 FPGA, the main Xilinx FPGA, the A200T, from programming up or staying programmed. And we need to copy that onto hiccup.m65 on the SD card. Unmount that. Plug that back in. And now what we can do, if I cut the power, obviously the screen will go off, and turn it back on. And goes into the, well, it may go into the flash menu. So now this is one of there's some slight non-determinism with this that goes on, which is a little bit annoying. What it should do is actually come on briefly and then go off. But because the keyboard goes through the thing normally, it's not reliably doing that. And so now it's doing the right thing. It will wait for a while, and now, this is actually might be funny, it will now on mine, because of what I've got in the different slots, it actually will come up eventually after those few seconds into the C64 core that I've got in, I think it's in slot 3 or something, right? Because what this Linus is saying, somebody needs to dust their MEGA65. Yes, my MEGA65 gets used rather than dusted on a regular basis. If someone wants to come around and dust it for me, feel free. So we can see that this is now doing what it should do. And I think that non-determinism actually depends where in the keyboard reading cycle at the hardware level things happen, and it can confuse the core as to thinking that the no scroll key is down, which can cause the freeze menu to appear instead of it doing the right thing. Anyway, the point being we can get it into this state. So the keyboard is still not working, right? Because the MAX10 isn't programmed. So what we can do now, though, if I get the right camera happening here. Okay, and let me go. Right. Okay. So we are going to reboot the machine again. Right, I'm going to power the machine off. So the screen will go off. And at the instant that I turn the MEGA65 on, I'm going to hit enter on that command on the Linux machine. The sleep through will make it wait 3 seconds, which is about the right amount of time. And hopefully it will then program up the MAX10. Now this isn't updating its flash because it takes longer, because this program only can keep the Xilinx FPGA unprogrammed for a few seconds while the main FPGA, because I'm telling it to start looking for a core in a silly place. And it reads through the flash memory quite quickly, and eventually it finds a valid core by wrapping around and goes, oh, that's what I'll start. But during that time, the JTAG on the MAX10 is enabled. So let's give that a go. And let's see if it'll work for us first time. Oh. It will work better if I have my sudo already entered in. Right. And it will also help if I actually have the JTAG cable plugged in. So the important thing is this is the JTAG for the it's the JTAG for the MAX10 FPGA, so not the normal JTAG that you use up in the back corner of the machine. If I go here, so the JTAG that we need to use at the moment is this one, not that one. You can have them both plugged in, that's totally fine, but this is the one that matters right now. Although sometimes actually on Linux you find it gets a bit confused if it's got both, so you could just unplug the USB from the computer end for the one that you don't need right at the moment. Oh, and hello along other people. Hello Herdware. We've got 8 of you on there now. It's fantastic. I hope that you're enjoying as we go through this process as well. Okay, so let's go back to there. Get that superimposed. Okay, so now that we've got the sudo done, I'm just doing a quick test without turning the machine off. Okay, you can see it's saying this can't scan JTAG chain. So this is the symptom that you will see from the Quartus programming tools when this happens. So I'm running this from the MEGA65 R2 MAX10 directory on my laptop, which has got a clone of the repository of the same name from the MEGA65 GitHub site, and I've built that firmware ready to go. So we've got the MAX10 firmware ready to install. Now that's a separate issue from this video to get that ready. If you get stuck in the situation, you can contact me or one of the others in the team and we can provide that for you. So anyway, let's turn the power off to the machine, give it a few seconds off, and turn it on as I hit enter. And look, we have happy messages, so this is a good sign. And we will see that the screen will come on. It will still actually now come up into the C64 core, which I'll go across to. But now what you'll see, let's get the keyboard superimposed, the keyboard works again because we've got that connection through. Now, if I turn the computer off now, the MAX10 FPGA will deprogram again because we haven't put anything into its flash. But the flashing takes longer than that little time window, so what do we do? It's actually, we're now in a good position because all we have to do now is deprogram the main FPGA, which we can do fairly simply. All we need is a bit stream, which is, it has to have at the start of a real bit stream and then not finish at the end of a real bit stream. So the easy way to make one of those, again, I've got lots of these. We can use the DD command. And you can say bin MEGA65 R3.bit. So some valid bitstream file that you've got hanging around. OF equals, we'll call it, what shall I call it? It's called, dprogram.bit. BS equals 65536. So tell the block size is 64K. Count equals 1. So now we have a bitstream file which is only 64K. And we can just send that across. So I'm using the M65 command line tool for that. You could use some other MEGA65 transfer tool, but again, the rest of the steps for this process are easiest done under Linux, so I would recommend just doing it under Linux and having the M65 tool handy. Run that. Now we can see the screen has gone black because we've just deprogrammed the MEGA65 main FPGA. But the wonder of having done that now is that we can run flash.sh from in the MAX10 firmware directory, because the main FPGA is now deprogrammed. That means that the JTAG is now constantly available, not just for those few seconds, on the MAX10. So you should just be able to run it, and it will detect it, and it's now thinking. Yes, Lightning's also saying that M65 happily also works on the other two platforms. Totally true, but as I said, the rest of this process is really designed around Linux. You shouldn't need to do it very often. If you need someone's help who has Linux, then do that, because that will be the easiest way. We kind of really, this process, because it is such an unusual thing to need to do, we're really only officially supporting it under Linux, just so that we don't have to duplicate the effort to work it out. And as I say, you shouldn't need to do this on a regular basis. So that's programmed the MAX10 FPGA. Flash. So in theory now, if we restart the computer, so let's get that up, and that should be superimposed now. In theory, if I don't know what I got zooming the camera out. My hand's just off to the side here, right? I'm just turning the MEGA65 off, so the keyboard light's gone off. And now turn it on. And what we should see, notice there's no ambulance lights. Well, sorry, there is. What if I screwed up now? Because in theory... Oh, you know what it is? See, it's gone back into the C64 core. I forgot the important step, which is once you've done all of that, you need to remove that hiccup.m65 file because it's still trying to tell it to go into this funny mode. But what you will notice as well is actually the keyboard is already working again because we've programmed the MAX10. So that's good. So I'm just going to take the SD card off to the side here, plug it into my USB reader. Deleting the file is pretty dull, you don't need to see me doing it on camera. Delete the file, unmount the SD card, put the SD card back in the 65. So now, when I turn the MEGA65 off, the screen should go off, screen should come back on, and we should see the normal MEGA65 boot process. Yay! And our keyboard is working. So we have gone through the complete process of debricking this MEGA65 that was in what is the most difficult state to work with because of all of that funny interaction with how the MAX10 FPGA gets in the way of some of the key input-output devices purposely on the MEGA65. So yes, and Leiden's just that. She said, yes, your brickup M65 is still there, but do note that the file as we supplied is called brickup.m65, but you still have to copy it onto the SD card, and there it has to be called hiccup.m65. Otherwise it will ignore it. So it has to be exactly that name. and the file has to be exactly 16 kilobytes and a few other things. So there you go. That is the complete process for debricking a MEGA65 that has, for whatever reason, the flash messed up on the MAX10 FPGA. And remember, when you're doing all of this, no micro SD card in the micro SD slot, otherwise it won't work. Cool. I think that's all we need to cover on that. So I hope that is helpful. If you're viewing this sometime in the future, having to have gone through this process, hopefully that's got you back up and running happily with your MEGA65. So yeah, go and have more 8-bit fun. See ya!